Hello guys, my name is Shishpal and welcome to my channel Maths Pirates. In this video, we will going to discuss about the existence of mathematical essence before the mankind. Let's consider a best example of a spider. Hope everyone is had an idea a spider, right? Which we frequently used to get afraid when we were in childhood. We used to be away where we see spider webs, right? But observe very carefully that spider or that spider web, such a fascinating design it is, such a fascinating connections the spider makes to make its own home, right? Such a fascinating symmetry that spider physical structure has. So symmetry in the sense, suppose we have a spider and we draw a line, a vertical line exactly at the middle, and you observe the left part and the right part. When we fold the left part towards the right, suppose you take a picture of a spider, the good whenever we fold the left part towards the right, the picture exactly overlaps to each other. Such a fascinating symmetry the spider follows, and such a fascinating symmetrical design that spider makes to create its home. It's like a regular polygon. In when we speak in terms of geometry, it is a regular polygon with the curved sides. Such an extraordinary design it follows to make its home, to give birth to its offsprings, etc. Now my question is, did the spider learn the constructions? Did the spider learn about measurements? Did the spider learn the geometry like we do today? Like Pythagoras theorem, we have many geometrical theorems, right? Did the spider learn all these things? No, right? That's the that's the adaptation. That's how spiders they adapted according to requirement. That's the beauty of nature. The patterns that we see all around us when we live in nature. Nature continuously gives us, makes us view to many patterns, periodic patterns around us, like passing of days, a single day, morning to night is nothing but a single day, right? The same scenario, morning, afternoon, evening, night, single day. Again, next day, morning, afternoon, evening, and night. Same, this the repetition of this pattern is called periodicity. The frequently repeated pattern is called periodicity. So understand the beauty of nature, the beautiful patterns does it follow, which we are giving the mathematical description in the present time using the concepts of geometry, complex numbers, etc. Let me take another best example, honeycomb. You all familiar with honeybees, right? And the nest honeybee makes to store the honey collected from flowers. See, in many of the channels or in practical, you might view the home of of a bee. You observe sequential connected hexagons, six-sided shape, closed shape, right? Repeatedly connected six-sided shapes, which are called as hexagons. Such a fascinating connection it is. Did the bee learned from human beings to create such things? That's my question. But there is no human interference for the species to make their homes, to make their patterns. They make in their patterns are completely individual, adapted through inheritance. Such a fascinating thing it is to notice. Repeatedly connected hexagons, where the honeybee store its honey. Another best example, observe the sunflower. If you look at the middle of the sunflower, you see such a fascinating design or arrangement, which we call it as Fibonacci series. When we numerically describe that pattern, it is called as Fibonacci series. Now, now understand, did all these things occurred in nature because they learnt mathematics? Did, did all these patterns exist because they learnt geometry or shapes? No, right? Currently, even in schools, we will be having a separate chapter like understanding shapes, right? Did they study such chapters to make such patterns for themselves? So, acceptance feels strange, but that's the truth. The fascinating build up, the fascinating structure through connected patterns in the nature itself. And let me take another best example, that is tree. Tree has different branches, right? Grown in different directions. In discrete mathematics, we learn the concept of tree structure. Especially if you are a computer science student, hope you are aware of tree structure, non as a non-linear data structure, which has a high weightage in your interviews as well. Did the tree solve equations? Did, did the tree learnt the way it should grow in order to get balanced? That's the design that nature made, right? The patterns, the nature continuously gives us a sequence of patterns, many patterns. And the essence of mathematics lies behind when the mankind started recognizing the patterns and making them as an abstract things as a part of discussion. The pattern followed by the branches for the growth of the tree, the pattern that honeybees follow to make their home, to store honey, the pattern that spiders follow to make their home for a comfortable living. When the mathematical essence lied behind when mankind started noticing, recognizing the patterns, the periodically repeated patterns as well as well shaped, well constructed shapes around them. And another example is distribution. When, for example, let me take a tribal community, a group of strong men who went out to hunt in the forest and get the food for the tribes. How did they knew how to divide that food so that everyone gets an equal share? Did they learn fractions and ratios like we do today as a part of mathematical foundation? No, right? It's a part of the survival. They adapted it so that they can survive in that circumstances within the tribe. That's what the true beauty lies behind mathematics. It was it came it evolved through survival. It was evolved with the necessity of survival, not in classrooms, not from teachers. This is all about the essence of mathematics behind the mankind, before the existence of mankind. Okay, guys, this is another philosophical aspect behind about mathematics. Coming up, let's meet in the next video again. Until then, bye bye.